Welcome back, guys. Thank you very much for staying with us. If you've just joined, you're watching Tenfold Live, coming to you live from our Johannesburg studio. This is one of the awesome shows that you always have to make sure that you watch because we are here to help you build your content. This week we're focusing on analytical geometry. We take your questions. You can send them through on WhatsApp as well as on our app, which is called the Tenfold Education app. A big shout out to Liberty, which is sponsoring our show. Thank you very much for that. So you can just keep sending us your questions and you stand a chance to win awesome prizes when you keep those questions coming in. We are continuing with our analytical geometry for this week. We will now go to a question that was sent to us by Bugala. Let's go check it out.
Hi, my name is Rapunga Bugala and I'm a Catholic grammar and I would like assistance with this question paper. This was a question paper which was written in 2017, paper 1. February March question paper, and I would like assistance with question 3.3. That's the diagram. Thank you.
Right. Oh, nah. It's a nice question indeed. I'm actually not happy that you didn't ask all of them, but very nice question indeed. We answer whatever you guys want us to look at. So Bugala just wanted us to look at one part of that question. It did indicate that you wanted us to focus only on one part. It would have been nicer if you wanted us to take all of them up, but then it's fine. Let's see what we can do with this. It's a simple question. I want us to look at it together and then analyze it and see how we can actually find the solution on this. Let's go and check it out. It says to us there is a diagram that is sketched for us there. In the diagram, there's a point Q. This Q is currently hidden. Let me show it to you guys. There it is at the bottom there, right at the bottom. That point Q is actually the point 3:0. And then there is another point R, which is lying on the first quadrant. It is the point 10:7. There's another point S right at the top with no coordinates on it. And then there's T, which is 0 and 4. These are vertices of a parallelogram. There's a lot of information that you could have found from the story of a parallelogram. Unfortunately, he didn't ask us to look into that. Anyway, this parallelogram is parallelogram QRST. From T, a straight line is drawn to meet QR. You can see there from T, there's a straight line that meets QR passing at point M. I hope you guys can see that. Right. Where M is the 0.5:2. The angle of inclination of TQ is alpha. The angle of inclination of RQ is beta. They are written there. Very nice to see them. Okay, cool. So now, there's a point F that is currently not on the sketch. Now, guys, this is big business in analytical geometry. In analytical, you get points or other coordinates that the examiner might talk about that are not necessarily on the sketch. So whenever you see that, your eyes and your mind work better with what you see than what you remember. So always update the sketch, put it there on the drawing, and then it's going to be easy for you to analyze what is going on. Without that appearing on your sketch, you won't be able to actually think much more logically. So as soon as I see a point F, which is not on a sketch, I'm going to go and update my drawing so that I can be able to think about it much better than just remembering it. Okay, cool. So now if we continue and try to look there, they say there's a point F, which is point K is to -8, and it lies on this Cartesian plane such that T, Q, F are collinear. Aha, there's the key word there, collinear. What does collinear means? It means that they lie on the same straight line. They lie on the same line. So I'm going to extend this line. The line they're talking about here, this one, which I'm now putting in yellow. If you extend it further there, you will notice that there will be another random point there, which is point F, given by the coordinates K is to -8. Not complicated at all. Very simple stuff that is currently happening here. So we remember that Q is 3:0, F is K is to -8, T is to 0 and 4. Now we are required to calculate the value of K. Very simple question. What you need to know about collinear points is that they lie on the same straight line. Therefore, the gradient of the points, the gradient of TQ is the same as the gradient of QF. Once I do this, I'll be able to actually work out what is going on. So let me work out the gradient of the line QQ. It is Y2 minus Y1 over X2 minus X1. I'm actually focusing on point T and point Q. That gradient will be the same as the gradient of QF, which is simply the Y at F, this -8 minus the Y at Q, which is 0, over the X at F, which is K, minus the X at Q, which is 3. Let's clean this up. 4 over -3 equals to negative 8 over k minus 3. Cross multiplication here, simple math. 4 times k will give you 4k. 4 times 3 will give you 12. Cross multiply 8 and 3, 8, 16, 24. It is positive 24. Transpose this to the right, then 4k becomes 24 plus 12, which is simply 36. If you simplify there, 4k equals 36. If you divide both sides by 4, your k is going to come out as 9. It would have been much nicer if you had asked us to look at all the questions, but I hope this does help you to understand how do you work with this. Collinear points lie on the same straight line, so the gradient of 2 points is the same as the gradient of any other 2 random points you can pick on that particular line. You could have also found the equation of that line and used it to find the value of k. It was still going to work out. So thank you for that question. Keep your questions coming in. We will now go to a very nice and awesome video that will help us to keep our analytical geometry fresh. We will look at the concept. We're going to a concept video that will help us to understand the theory behind analytical geometry before we continue with our analytical geometry. Remember, we are revising here. Let's go check out this video, and then after this, we are continuing with more questions from you guys.
The general equation for a circle with the center at the origin and radius r is x squared plus y squared equals r squared. Here is a circle with the equation x squared plus y squared equals 16. It is centered at the point 0 and 0 and has a radius of 4 units. You can take any point P on the circumference and make a right-angled triangle using the radius. That means that you can use the theorem of Pythagoras to calculate the radius of the circle using the x and y values of point P. What happens when the circle does not have the center at the origin 0, 0? Consider a circle on the Cartesian plane with the center at A, B, with a radius of r units. So the circle is the set of all points x, y that are r units away from the center AB. To find the length of the radius, we can use Pythagoras again. This is actually the same as using the distance formula that you know. If you make a right-angled triangle using r as the hypotenuse, you can work out the lengths of two sides of the triangle. The length parallel to the x-axis is x minus a, and the vertical length is y minus b. So the radius squared equals x minus a all squared plus y minus b all squared. Note that if a is 0 and b is 0, then the equation will be r squared equals x squared plus y squared, which is the equation of a circle with center 0, 0. This equation is very useful. We can easily see that AB is the center of the circle and R is the radius. In grade 12 analytical geometry, we have established that the equation of a circle centered at A, B with radius r is r squared equals x minus a all squared plus y minus b all squared. Now we look at tangents to circles. Remember that a tangent is a line that touches the circle at only one point, the point of contact. A tangent to a circle is perpendicular to the radius of the circle at the point of contact. A tangent is a straight line, so you can find its equation using a point and the gradient. In the diagram, CBD is a tangent to the circle with the center A. CBD is perpendicular to the radius AB, so the gradient of the tangent M subscript CD times the gradient of the radius M subscript AB is -1.
Wow, there you have it. Analytical geometry in a nutshell. If you feel like you loved that video, guys, you can access that video and even more exciting videos that are like it. Just go and download the Tenfold Education app. It will give you access to these kinds of stuff and even a lot of other things. Remember, you can also use the app to stream the show live and watch us if you find yourself somewhere along the way, maybe on your way going home or wherever you might be. To watch the show, you can just use that app. It's called the Tenfold Education app, available on iOS, also available on the Google Play Store. Remember, we are proudly brought to you by Liberty. A very big shout out to Liberty for sponsoring our show. We really appreciate everything that we're doing here. We hope you guys are benefiting from this. Remember, this is specifically created to empower you. If you keep sending us your questions, like we always say, guys, all the time, send us your questions on our WhatsApp line, or also use the app to send us these questions. You stand a chance to win awesome prizes. Awesome prizes. One person who has done exactly that is Sipho Senkosi. Sipho Senkosi, congratulations. You just won yourself a 19-inch TV. You won yourself a TV for just sending us your question. Thank you very much for this. Congratulations to you. We will be in touch with you to give you your prize. We're now going to go and check what Sipho's question was saying.
Hey guys, my name is Posenkose from Eastern Cape. I'm schooling at Bizana Village. Can you please assist me with this question?
Right. By just looking at that question, I can see a lot that relates to the video we just looked at, guys. That concept video was very powerful because it actually outlined all that you need to do in order to answer this question. So I want us to look at it again before we analyze it further and see what is going on with the statement and how do we actually position ourselves to answer this question much nicer. Let's look at it. It says to us here in the diagram below, there's a circle. We can all see that. And this circle that we're looking at apparently has a center at point M with the coordinates 5 and 4. This circle touches the y-axis. Aha, touch. Touching is a very powerful word, guys. This touching here that I'm looking at tells me that there's a big chance, if not a certain situation, where the y-axis is in fact the tangent. Because it touches the circle, it's the tangent to that circle. It's tangential to the circle. Right, at point N. And it intersects the x-axis at point A as well as point B. PBL, there's a line PBL, it's a straight line that is increasing right there, is also another tangent. So we've got the second tangent there, right? And SKL are tangents to the circle where SKL is parallel to the x-axis. P and S are points on the y-axis. LM is drawn. Okay, fine. Very simple, not complicated at all. Right, now what are the questions here? Let's go and check what the questions are saying to us. The first question that we need to worry about says to us, write down the length of the radius of the circle having the center M. All right, cool. We need to find how long the radius is. Remember, the radius is the distance from the circumference of the circle to the center of the circle. Now, when you look at this one, the way it is positioned, we are going to use the fact that we were told that point N is lying on the y-axis and point M is the center of the circle. We don't have much information. There are no points here. I don't have coordinates of K. I don't have coordinates of B or A to work out the distance of the radius. But I'm going to use the fact that I know the coordinates here at point N, that this straight line that you can draw there is basically the radius of the circle. That line is the radius of the circle. According to this, our x coordinate is 5. That means from the x-axis, you have moved 5 units to get to point M. And that definitely has to be the radius of the circle. There is no two ways about it. To move from point N to go to point M, you're moving 5 units along the x-axis because we can see the x coordinate is 5 there. That definitely means that our radius is in fact equal to 5 units. That is basically what our radius is going to be. A very simple question that just required you to analyze it by thinking about the meaning of the fact that the y-axis is perpendicular to the radius. So we could have used that to work out what the length of the radius is. Let's move right along to the next question. Right. The next question says to us, write down the equation. Now we need to find the equation. Okay, fine. Of the circle having the center M. In the form x minus a squared plus y minus b squared equals to r squared. If you were listening very well, we were told from the previous video there that this a and this b are coordinates of the center. And our center is M there. Since these are the coordinates of the center, the first one is 5 and the second one is equal to 4. I already have the coordinates of the center. The radius, we just found it from the previous question, and we found that the radius value is equal to 5. So this is another very straightforward question. X minus 5 squared plus y minus 4 squared equals to 5 squared, which is just equal to 25. Nice question again, very simple and straightforward. It is what we call a knowledge question. You know the coordinates of the center, you plug them there. You know the length of the radius, you just plug there, and then you are done with the question. Let's move on to the third part of this question. It says to us, let's look at it. Oh, there you have it. Remember, the equation of the second is now x minus 5 squared plus y minus 4 squared equals to 25. We now have to figure out something very interesting. You are told to work out the coordinates of A. Now, from the opening statement, we were told that A lies on the x-axis. It is basically the x-intercept of this particular circle. So I already know that once I see stuff like this, I already know that one of the coordinates is given there. And we don't know what the x-coordinate of A is. We don't know this, but we are certain that the y-coordinate is going to be a 0 there. So what I'm simply going to do is I'm going to take these two things and just substitute into the equation of the circle, because the circle does pass at that point A. It's just as good as saying we are working out the x-intercept of the circle using the equation of the circle that was given to us, or the one that we just worked out. Okay, cool. So let's see now. I'm going to substitute my x value as x of A. There's x of A minus 5 squared plus the y-coordinate at A, there is 0. So I'm putting 0 minus 4 squared equals to 25. The rest is just basic algebraic simplifications. Let's do math. X minus 5, close brackets there, squared. This is 0 minus 4 squared, which is 16. So I'm going to have 25 minus 16, which is going to give me x minus 5 squared equals to 25 minus 16, which gives me 9. Right, now if I continue with this, I'll simply sit with x minus a minus 5. To remove the square, remember, you just need to introduce a square root. So I'm going to put a square root on the left and put a square root on the right hand side. Remember, a square root must always be accompanied by plus minus. All right, cool. So now this is basically going to become plus minus the square root of 9, which is going to give you 3. If you continue here, you'll simply have x of a equals to positive 5 when you take 5 over plus minus 3. So the x value of a, right, can be 5 plus 3, which is 8, or it can be 5 minus 3, which is 2. According to this drawing, the two x values that I'm getting here are telling me that the circle cuts the x-axis twice, when x is 2 and when x is 8. So we need to check which one of the two corresponds to the point A. According to this sketch, clearly you can see that. I don't even know what is going on with B, but I can tell you that this is going to be 2 is to 0, and B is likely to be 8 is to 0, because it's another x-intercept there. But nobody's saying anything about B, so we're not worrying about it. We just wanted A. The coordinates of A are 2 is to 0. Let's move on to the next question of this very nice, interesting question. The next part says to us, we need to find if the coordinates of B are, there we have it. They are telling us now. If B is 8 is to 0, we need to calculate the equation of the tangent PB. There's the tangent PB in the form y is mx plus c. All right, fine. For us to find the equation of a straight line, a tangent is a straight line, we need to use the fact that y is mx plus c. We must firstly find the gradient, and we have a point 8 is to 0. We can be able to use this. Now, we will manipulate one of the things that I saw on that video that said a gradient of the tangent perpendicular to the gradient of the radius will give you -1 when you multiply them. We already know the point M and the point B, so I can actually simply work out the gradient of the radius, which is y2 minus y1. It's 4 minus 0, right, over 5 minus 8. 5 minus 8, which is simply going to be 4 over -3. But that is the gradient of the radius. However, the gradient of the radius times the gradient of the tangent must give us -1. Why? Because a tangent is perpendicular to the radius. A tangent and a radius are perpendicular to each other. Very simple. So if this one is -4 over 3, therefore the gradient that we are looking for of the tangent will just be positive 3 over 4. So that when you multiply them, you'll get the answer of -1. Now let's see what will happen. Y is mx plus c. My y value at point B is 0. My gradient is 3 over 4. The x value is 8 plus c. If you simplify this, you're simply going to end up with something very easy. 8 divided by 4 is 2, so 0 is 6 plus c. Therefore, y equals to 3 over 4 x minus 6. Because from this part here, when you transpose 6 over, you're going to get C equals to -6. So this is the equation of that line that you're talking about, which is the other tangent that is passing through point P and point B. Remember that the tangent is perpendicular to the radius. You don't have enough information for the tangent, but you have enough information for the radius. You work that out and then use the fact that M1 times M2 is -1 since they're perpendicular. You'll be able to get what you're looking for. Thank you very much for that question and congratulations for your prize. We are still coming back with a lot of exciting questions. There's still a wild card coming your way. So stay tuned. Don't go anywhere. We'll be right back.